All right, so physics gurus, you're studying Newton's laws of motion, and now it's time to study all three of those laws together. So each one of those laws explains how things move just in a different way. So imagine this scenario here. I have a small boy wading in the ocean, and so you can see that they have the ocean waves lapping at his feet. And so imagine that this large ocean wave comes to exert a force on him, and he may be knocked down and that kind of thing, but I want to take a picture of that at least. So you could explain that ocean wave hitting the boy using all three of Newton's laws. So again, it's just a different way to explain how things move, how they act. So the first law, you know, is already the law of inertia. So we talked about how that's an object in motion. Will continue that motion unless acted on by an outside force. Or the same is true as at rest. So if he is just standing there, we're going to say that he's not moving. His velocity is 0. He's not going to move unless a force hits him. Okay, so that's how you would explain it using Newton's first law. So if he's standing there, he needs a force to make him move. Okay, now using the second law, you have a little bit more mathematics involved in it. So acceleration equals F net over m, and we talked about how the acceleration is directly proportional to the size of the net force in the same direction of the net force and inversely proportional to the mass of the object. And hopefully by now you're starting to make sense of what that all is. So if you have a boy and has a small mass, when the wave comes, and the bigger the wave is, the more force that it exerts on him, he will accelerate more. So more force means you're going to accelerate more. If I had a bigger person on there, they won't accelerate as much. So, you know, when you change the mass of that, the effects of the force also change. So that's explaining it using Newton's second law without using the numbers in the math. Now the third law sometimes is referred to as action-reaction laws. So you know that those forces always occur in pairs. So they are equal in size and magnitude and opposite in direction. Now the key thing to remember is that the ocean wave exerts a force on the boy is going to exert a force back on the ocean wave. Okay? Now the forces are all the same, but remember the forces are acting on different objects or different things. So one is acting on the boy, one is acting on the ocean wave. Okay? Now using that third law, you can start to compare those two things. So if I know the force is the same on both the boy and the ocean wave, you can look at how the effect of that force would be different on the different objects. So you know that force equals mass times acceleration. Now the boy is going to have a really small mass compared to my ocean wave mass. All right? Now if I have a smaller mass on the boy side here, but it still has to equal the same force, we're going to have a huge acceleration on the boy. All right? Small mass, big acceleration. On the other side of the equation, if I have my ocean wave that has a huge mass, it's not going to feel the acceleration that much. I mean, it has a very, very tiny acceleration. Now, a key thing to know that one of those has to be negative. Now, you decide which one is negative because that's just the direction. So the mass of the ocean wave is really, really big compared to the really, really small acceleration. Okay? So every action, everything, every motion that you do can be explained using all three laws of motion. Thank you.